Okay, in this video we're going to talk about polarization. We talked about how light is a varying electric and magnetic field, and if we remember, the electric field is a vector. Maxwell theory tells us that the direction of the electric field, the direction of the magnetic field, and the direction the light ray is traveling in are all perpendicular to each other. But this still leaves us with quite a few, if we know which way the light is traveling, this still leaves us with quite a few possible options for the direction the electric field that makes up the light could be pointed in. For example, let's imagine that we had a piece of light that was coming straight out of the screen at us. I use the notation we used way back when we were studying electric and magnetic fields to represent, that's supposed to be like the head of an arrow, so that represents something coming out of the screen. The electric field could be in any direction that's perpendicular to that. It could be like this, could be like this, could be like this. The direction that electric field is facing is what we call polarization. If the electric field is straight up and down like this guy, we call this vertically polarized light. If the electric field is side to side like this, we call this horizontally polarized light. And here we can see that we can have a mix of both vertically and horizontally polarized light. Some light sources, due to the nature of the way they make light, are naturally polarized. For example, a laser's light is naturally polarized when it comes out. But most sources of light, like incandescent light bulbs or the sun, produce a light that has a random or a mixed polarization. It would have some of each of these directions for its electric field, and really different photons of light would all have their own polarizations. This is interesting. Oh, just as a quick reminder too, if the light was traveling this way and the electric field happened to be up, so this is the velocity of the light, this is the electric field of the light, we would say the magnetic field is the third 90-degree angle there. Sorry, going on. The reason that polarization is important is because it's something that we can, once we polarize light, it's something that we can take advantage of for some technologies to help us control light in the way that we view light. I'm going to describe two interesting technologies here. I'm going to talk about 3D movies, and then I'm going to talk about polarized filters for sunglasses or cameras. So one of the ways that our brain creates depth when we observe things is if an object is located at some location here, then we get two signals of where it is. And based on how those track together, we get an idea of what distance it is away. See, if an object is near, it's going to have a pretty big angle here, and if an object's far, it'll naturally have a smaller angle. So that ability to track from both of our eyes, getting a separate picture, allows us to see how deep an object is when we're viewing it. We can exploit this with a movie if we can imagine if we were taking a movie of this thing here using two separate cameras. If we could get this camera to represent this eye and this camera to go into this eye, then we'd be able to let you have the same ability to judge the depth of this object. What that's going to let us do is it's going to let us see these things in 3 dimensions. So how are we going to do that? Well, one of the simpler ways is to take the movie in the two cameras separately, and then when you're projecting it onto the screen in the movie theater, you project it with two separate projectors. So you project one image, the image that would be for the one eye, and then you project the other image and you project them from the other eye right on top of each other. Now if you look at this with both your eyes and no polarization filters on, it just ends up looking like a blurry mess. And if the next time you go to a movie theater you want to take your 3D glasses off, you can see those two images right on top of each other and how it creates a blurry mess. But if sitting out here in the seats, you're wearing a pair of glasses, If I do this with, say, vertically polarized light, and this with, say, horizontally polarized light, then I can polarize one of these glasses in one direction and the other glass in the other direction. What that allows me to do then is to make it so that this light only goes through this eye and this light only goes through that eye. And that way, you're getting the two separate cameras going to your two separate eyes, and you're able to recreate the depth that would have been observed by the cameras when the original picture was taken. And as a result, the image will appear in 3 dimensions. So in that way, we've used polarized light projection and polarizing filters to get those two images to only go into the one right eye respectively, and as a result create a 3-dimensional image. As a secondary idea, since light from the sun is randomly polarized, so we'll have some vertical and some horizontal, and when it hits random objects and bounces off towards a secondary viewer or a camera or something like that, it's still randomly polarized. But when it hits the ground, we find out that most of it becomes horizontally polarized upon reflection from the ground. We can filter out light reflected by the ground primarily using a pair of filters on these glasses. If we make our glasses with vertical polarization, then the random light from reflecting from interesting objects will pass through at about 50%, and the light bouncing off the ground, or the glare that we might see, say, from the top of a lake or from some snow or something like that, that's bouncing off primarily horizontally, will not get through. This object will appear a bit dimmer, but if we're imagining we're in high light conditions, that shouldn't be a problem. But the glare will get blocked. What this means is I might be able to take a better picture of somebody that's standing around a lot of flat surface where there would have been a lot of light reflecting off that surface by getting rid of that horizontal light. Or if I want to, say, go fishing, then I can see perhaps more into the water by getting rid of the reflection from the top of the water and getting the randomly polarized light that comes from hitting a complex shape like a fish under the water. So we put a polarization filter on our sunglasses on our camera to let us focus on the light that gets reflected in random ways as opposed to the light that gets reflected off of large flat surfaces. There's a lot more ways that we use the polarization of light. I just picked a couple ones that I thought were interesting. But that's what light polarization is, and we can exploit this to get light to go where we want it to go and not go where we don't want it to go.